We talk a lot about option modules as well. So you describe the core physics that everyone has to do, but then on top of that, we have our options modules, which give you flexibility throughout your degree. So straight from year one, you can start making some choices about the kind of things you want to study on top of the core. And so the general flavors that we talk about, you can graduate with a physics degree, a physics with space science degree, and a physics with astrophysics degree. And one common question that people often ask is, what is the difference between space science and astrophysics? Because they probably have encountered astronomy or astrophysics through various mechanisms, maybe from school, maybe from an astronomy club, maybe from reading books or watching the sky at night. But not many people have tackled space science, or at least sort of aren't really aware of what the differences are. So Simon, can you just briefly explain what the difference between astro and space is?
Yeah, so I think the very rough definition most of us would be happy with is somewhere on the edge of the solar system, we change from being interested in space science to being interested in astrophysics. So space science might include Earth observation science, so satellites looking down. It might be the orbital mechanics, how do we launch things into space, how do we maneuver from one planet to the next, up to the studies of planets, planet formation within the solar system, solar wind, interaction of the solar wind with gas giants, moons, etc. All of that would come under the umbrella term of space science. Once we're outside of the solar system and we're talking about stars, they may be nearby stars other than the sun, right up to stars on the edge of the galaxy, center of the galaxy, structure of our galaxy, evolution of elements. So where did the heavy elements come from? Answer, they come from supernovae. Dead stars like white dwarfs, neutron stars, black holes, galaxies, evolution, quasars and cosmology, those would all count as astrophysics. So very roughly, draw a boundary somewhere towards the edge of the solar system. It's a fuzzy boundary, and that would be the main difference. Of course, there's overlap. I use space telescopes. Got to know a little bit about space science to know how to use a space telescope and what it can do, what its limitations are. So there's overlap, and the subject of planets is now sat firmly within both camps, because we can learn about extrasolar planets by studying the solar system and learn about solar system formation by studying planets around other stars.